All right, guys, we are going to go ahead and look at this insanely long review for your test that's coming up. I mean, it's actually not that bad. What is it, 16 pages? But it's only like 40 questions, so I don't know. Let's see what we can get here, okay? Also, it's obviously a lot of it is cut and paste, like literally cut and pasted from old stuff. So let's go ahead and get going, all right? Remember the things that we're covering on this chapter. We're looking at implicit differentiation. We're looking at derivatives of derivatives of trig functions. We're looking at inverse derivatives. We're looking at L'Hopital's rule and mean value theorem, okay? So let's take a look here. This first one, this is an implicit problem. Okay, go ahead and move myself down here. The derivative of sine x is cosine x. Remember, I don't have to do anything with that, like dx, because it's in terms of x, right? Okay, the derivative of cosine is negative sine y. That one needs a dy dx on it. The derivative of 2 is 0, and the derivative of 0 is 0. Two negatives make a positive, so it's cosine x plus sine y dy dx. Okay? All right, so let me go ahead and solve this. I'm going to subtract cosine x over, and then I'm going to divide by sine y. Okay, so I get dy dx is negative cosine x over sine y, which is perfect. Now, let's talk about how AP test writers try to mess with you. All right, here we go. First, they're like, look, there it is, cosine x, sine y. And they make you think, oh, you know what? I probably messed up and there's not really a negative there. Nope, there really is a negative there. It's not that answer. Okay? And then they make you think, oh, cosine over sine is cotangent. Yeah, it's got to be that. Except that, look over here, guys. This is an x. This is a y. You can't combine an x and a y. All right, if they were both y's, it could be that. So, nope. All right. Same thing here. They're trying to do the same thing with you with the x's, but it's an x and y. It's separate. This answer is if you forget that the derivative of 2 is 0. That's that answer. So, like, what the heck is this? Okay, check it out. There's cosine x and sine on the bottom. Well, you guys, sine on the bottom is the same thing as the reciprocal of sine, which is, move that over, cosecant. That's this answer. That's pretty mean though, right? So you really got to be careful on multiple choice stuff. Don't just assume, oh, I made a mistake. Like, look if they wrote it in a different way. All right? All right, here we go. On number 2, we are looking for our second derivative. Second derivative, okay? Cool. So let me come down here. The derivative of x squared is 2x. The derivative of y squared is 2y dy dx. And the derivative of 25 is 0. Okay, if I subtract the 2x over, subtract that to the other side, and then divide both sides by 2y, okay, I get dy dx. I can go ahead and cross out those 2's, get negative x over y, okay? So now it's time for me to do my second derivative. And in that case, I'm going to have to do a quotient rule, okay? Now, a quotient rule, what I'm going to do is I'm going to go derivative of the top times the bottom minus the top times derivative of the bottom, which is dy dx, over the bottom squared, okay? So I can write this as negative y plus x dy dx over y squared, all right? You guys, I can plug in 0 for x, 5 for y, but I guess my question is, so what are we going to plug in for dy dx? Well, if I go to here and I plug in 0 for x, and 5 for y. dy dx is also 0, okay? So now I'll go ahead and figure out what d2y dx2 is when I evaluate. So it'll be negative 5, because that's what y was. X was 0. dy dx was 0 over 5 squared. Okay, so it's negative 5 over 25, or negative 1/5. All right, so there's my answer for that one. Okay, cool. Equation to the tangent line. We love that, right? As soon as we see the words equation of the tangent line, we write y minus y1, mx minus x1. This is x1, this is y1. We can go ahead and look at our answers right here, but actually it doesn't really help me very much because all of these say y plus 3 and all of them say x minus 1. So really the only difference is now finding the slope, okay? Now remember guys that the slope is the derivative at that point. I'm going to have to do implicit on here, okay? The implicit derivative would be 2x. And then for this part, you have to do a product rule, all right? I'm going to let negative 3x be my first product and y be my second product. So we're going to go derivative of the first times the second. So negative 3x times y. And then the first times derivative of the second. All right? So it's my product rule. And then the derivative of 10 is 0. So remember when we're solving these, anything that is not a dy dx will go on the opposite side. And when I move those over, we're going to make them negative. So negative 2x plus 3y. And so to solve for dy dx, I'm going to divide both sides by negative 3x. Okay, so this is my equation for dy dx. Come back up here, x1 is 1, y1 is negative 3. So I'm going to put 1, negative 3, and 1. So I get negative 2 minus 9 over negative 3. It's negative 11 over negative 3, which is 11/3. So that's my slope. So that would go right here on my equation of my tangent line, and I will pick that one. Okay? Okay, let's see here. There we go. All right. This looks like an inverse question. Okay, inverse question. Tells me f of 3 is 8. F prime is 3 is 5. What's the inverse of 8 and what's the slope at x equals 8? Okay, interesting. Well, the inverse is just kind of asking this right here. You guys, sometimes when I'm using f and f inverse, I don't really like that very much because it confuses me. And if it confuses you too, you are good to go ahead and change f inverse to g and just like change it back at the end. But anyways, because that's like what we're used to. But if you're okay with inverse, then that's fine. All right. If f of 3 is 8, f inverse of 8 is 3. So we always take the original point and we switch the x and y, okay? So that's the first thing it asked me to find. Now it wants the slope of f inverse at 8. So it's basically asking me what's f inverse prime. I don't know, I'll put it like out there, right? Okay, well, you guys know we go 1 over. We switch this. So instead of using f inverse, or if it was like g, I would switch it and use f. And instead of using 8, we use the magic number that goes with 8, which is over here. 8 is 3. All right? So g prime of 8 is 1 over f prime of 3. It's like weird to write f inverse prime, but there we go. And I know from right here that f prime of 3 is 5, so this equals 1/5. Okay, so it just goes to show you that the slope of that, so we can call that like prime, is 1/5. All right. Awesome. Here's another implicit problem. This is going to start with a product rule right here. derivative of the first times the second, plus the first times derivative of the second. The derivative of negative 3x is negative 3. And then on the other side of the equals, the derivative of y to the third is 3y squared dy dx. And the derivative of negative 3 is 0. I want to get all my dy dx's on the same side. So what I'm thinking is I'm going to take this one over here. Okay, so that leaves 2xy minus 3 on that side. 3y squared dy dx minus x squared dy dx on that side. And then you guys remember I told you, you factor out a dy dx. And that equals 2xy minus 3. And then we divide that over. Okay, so that's my equation for dy dx. I come back up here and I say, okay, x is negative 1, y is 2. So wherever I see an x, I'll put negative 1. Wherever I see a y, I'll put 2. Okay, 2 times negative 1 times 2 is negative 4 minus 3. Remember to square first. 2 squared is 4 times 3 is 12. Negative 1 squared is 1, and that's a minus, so it's negative 7 over 11. Okay, so I will go with that question there. All right. Okay, perfect. The functions f and g are differentiable. Now, why does it tell me this? What's the point of that? Well, you guys, that's the definition of these are inverses. So it's no different in the way that we do this problem. It would be the same thing as if instead of writing that, they just put f and g are inverses. Okay, so here's how it goes. Well, g of 8 comes from here. If I flip that around, if f of 3 is 8, g of 8 is 3. Okay, so I can get rid of those. And then here's how this part works. You guys remember this. G prime of 8 is 1 over f prime of magic number that goes with 8, right? Well, 8 goes with, right here, 3, 8 goes with 3. So that number is 3. So I just have to go find that. F prime of 3 is 9. 1 over 9. All right, so it'll be E. Okay, taking a look at number 7. This is a implicit question. So y squared is 2y dy dx. This is going to be a product rule. The one thing too, you guys, when I'm doing a product rule on implicit, like that negative, I'm going to include that with my first term. So my first term will be negative 2x squared. My second term will be y. So it's derivative of the first times the second. And then first derivative of the second. Okay, derivative of 8 is 0. Everything that has a dy dx will stay on this side. Everything without will go to the other side. So this will say 2y dy dx minus 2x squared dy dx equals positive 4xy. I added that to the other side, okay? Factor out a dy dx. And then just divide this whole thing over. Now, when I go and look at this, I don't see that option up there. So we got to figure out how to reduce this. Well, look, the only way that you're allowed to reduce these is if you can take the same thing out of all three terms. So as an example, I'm not allowed to cross off x and x because I can't take one from there. Or same with y, I can't cross off because I can't take one from here. So it has to be from all three. So if you look at this, what can I take out of all three? Well, a 4, a 2, and a 2. So I can take out, make that a 2, a 1, and a 1. Okay, so then my answer would look like 2xy over 1y minus 1x squared. And then that's one of my answers. All right, so just make sure that you're simplifying that properly. See, these are like copies of copies of copies. So these things are getting really blurred. One of these days I'll retype everything. Okay, if e to the xy equals 2, then at the point 1 ln 2, what is dy dx? All right, so here's our implicit. The derivative of e to the xy is e to the xy. And then because of chain rule, I have to do derivative of the power. Okay? That's derivative of x is 1 times y, and then x dy dx. And we know that the derivative of 2 is 0 because that is a constant. All right? Now I can solve this for dy dx, or I can plug everything in right now. I'm actually able to do that, right? So I don't actually have to solve for dy dx right now if I don't want to. I can plug in that for x, that for y. Okay, so look, it's e to the 1 ln 2. Then that's ln 2. And then that's 1. dy dx is 0. Okay, e to the ln 2 cancels out. So 2 times ln of 2 plus 1 dy dx is 0. I can distribute the 2. Subtract the 2 ln of 2 over. So 2 dy dx equals negative 2 ln of 2. And then divide by 2. Okay, so just a lot of algebraic manipulation to get me to negative ln 2. All right. Cool. Remember that arctan means the same thing as inverse tan. We have a formula for that, and I will have the formulas up on the board during your test. So you would see this. The inverse tan is 1 over 1 plus x squared. So that, you'll see that. Now, you've got to memorize that eventually, okay? Okay, so what would the derivative be? Okay, well, inverse tan is 1 over 1 plus something squared. And the something that I'm squaring here is sine x. And then the derivative of the inside, okay, derivative of sine is cosine x. All right, so I can write this as cosine x over 1 plus sine squared x. All right, and I would just leave that one like that. Okay, and then here's another trig one, arc cosine. So again, on the board, you would see the derivative of inverse cosine x is negative 1 over the square root of 1 minus x squared. All right. Okay. Slope of the tangent line means derivative. So derivative of this is negative 1 over the square root of 1 minus that squared, because that's what's on the inside, times the derivative of that. Now, we've talked about this before, you guys, but the derivative of x over 2, think of it as 1/2 x. The derivative is just 1/2. Okay, and I'm plugging in, I'm evaluating this, negative 1. So that's negative 1 over 2 squared times 1/2. Okay. Let's figure this out. Negative squared is positive. 1/2 squared is 1/4. 1 minus 1/4 is 3/4. So this is, let's see, negative 1 over the square root of 3/4 times 1/2. Well, if I'm right here, this is, I'm dividing by a fraction. So I'm going to go ahead and multiply by the reciprocal. So the negative is still there, but instead of square root 3 over 4, it's going to be square root of 4 over 3. And you guys, the square root of 4 right here is 2. So it's going to be negative 2 over the square root of 3 times 1/2. Ooh, look at that. That crosses out. So it should be negative 1 over square root 3. Okay, so that's the answer that we got for that one. All right, so that was questions 1 through 10. So we'll take a break on this video, and then we'll do 11 through 20 next.